Hi, this is Roger from Kanka Labs, and today it's about two samples of these so-called Wimshurst-Machines that, as you already can see, they are of Chinese origin. And I always wanted to have one of these because they are a very early type of high voltage generators. Functional models can deliver up to 100 kilovolts, and they were developed more than 100 years ago, and I always wanted to have one of these. And at the start of the pandemic I was looking around at AliExpress, and there they are selling such Wimshurst-Machines for something around 50 euros plus shipping. And so I thought, well, let's give it a try. And this is the first one I got. I cannot demonstrate you how it works simply because it doesn't work, and we will see in a minute why this model cannot work at all. But at least we can take a look at some of the parts and how they are manufactured in China. If you want to get a deep understanding of how this induction machine or electrostatic generator works, you can look it up at Wikipedia or take a look at one of the many YouTube videos. Anyway, what you can already realize are these two Leyden jars. They are a very early type of capacitor, and they are even today suitable as high voltage capacitors. And let's take a look inside, because when this model here arrived, everything was completely warped. All the plastic here was warped. The cardboard shipping box was totally soaked by water, and it was really a mess when this arrived here. And the first Leyden jar here was already loose, and you have an outer layer of a conductive material, then an isolating, in this case plastic. In the original Leyden jars this was of course glass, and you have an inner coating with a conducting material, and then you of course have some electrodes. Of course you have to make contacts from the inside coating to here, this metal thingy here above. They did this with a let's call it a self-wound kind of spring. But what made me suspicious that there is something wrong with this and this cannot work, this looks like aluminium paint, and this should be conductive. But let's try out with a multimeter if this really is conductive, because that's of course the presupposition that this can store some charge. And I don't know what is the largest value that the 121GW from Dave Jones' EV block can measure, but must be something around 40 megohms or 50 megohms, and you can see even these are quite pointy probe tips. There is no, if I leave out fingers, there simply is no conduction. So this looks like aluminium paint, which should be conductive, but it isn't. Once again, I even try to test it with my insulation tester, which can measure up to 2 gigohms, but even there I didn't get a display. I can try to repeat this, although this is not the right setup here. But let's see. And it would need 3 hands to do this. So let's see if we can measure anything. So nothing up to even not 2 gigohms. So this is not a conductive material, and if you don't have any conductive materials, you don't have a capacitor, and this can store no charge. So this cannot work. But that is not all. We will take a look at some other of the parts and see what else, what other reasons there are why this cannot work? Well, except for the two Leyden jars as capacitors, you can see this here is intended as a spark gap. You can change the distance between these, and you can get, in a working Wimshurst-Machines, you can get sparks as long as a few centimeters. The better the Wimshurst-Machine is designed, the longer the sparks. With 100 kV you can even get to 5 or 10 centimeter long sparks. Then you have here this kind of combs for taking off without touching these rotating discs. You might perhaps know that at high voltage, if you have a pointed tip, this can emit charge as well as receive charges. The two tips are pointed as near to the rotating discs as possible, which is another thing here that is, due to the mechanical instability, is nearly impossible to achieve. And then you have these two what's called neutralizers. You can see on the rotating discs there are a lot of segments also made of conducting material. This looks like the same aluminium paint, or what should be conductive aluminium paint that is used for the Leyden jars, but there is simply no conduction. I've already also measured these, and you have these two metal bars here, and at the end there are some brushes, and two opposing segments are always neutralized by these. There's one on the front and one on the back side, and here you can see the crank. And if I turn the crank, you can see the two discs are rotating in opposite directions. That is necessary for a correct working of a Wimshurst machine. And this is the only thing of the whole apparatus that is working after you perhaps can see still how warped this must have been when it arrived. It still has some, it is still bent a little bit, but at least I could manage to get this thing rotating. And you can see, if you look from the side, the two discs are not very parallel, which is basically also necessary. And what's worse, these brushes that neutralize the charge on two opposing segments, they are made of these brass wool, or they are made of brass, like a brass metal cleaner, like these here. This is used for cleaning metals of corrosion or paint or anything else. And if you use something that is used for scratching off, what happens, of course, is, perhaps you can already see this, it will take not longer than a minute until, even if this would be conductive, it would be simply scratched away. So this is complete bullshit. This can never work, and you would have a very long time to botch this, or you would have to make this working. You would recoat the Leyden jars with some material that is really conductive, as well as these segments. You would have to replace these brass brushes. Well, the best alternative is simply desolder wire. Let's show you an example. Now you could either take a BNC cable or a shielded cable and use the copper shielding, or you simply use solder wick. And if you separate the single strands a little bit, the single wires, then you get a very fine non-abrasive brush to neutralize the charges. So this thing was complete bullshit, and it was a complete waste of money. So I thought, okay, let's write this off and try a second one which looked much better, and which I'll show you in a second. So this is the second model, which looked much better at first hand, except that it has a plastic base instead of the wooden base of the first model. But this looked like aluminium tape, which should be conductive. And let's try to measure this. By the way, you also get a manual in fully probably Cantonese, Chinese, where everything is explained very well. I even scanned the pages and uploaded them to Google Translate, and you really get a halfway decent translation out of Google Translate with the scanned or photographed pictures. So let's see if we here can measure. Aha, this looks already better. Yes, they are conductive. So that is already better. And although it's the same material and the same way they managed to do this, a lot of the things are loose, like here one of the arms or the bars of the neutralizer, and you would have to tweak this still to make it working. And here everything is loose, and the screws are not the way they should be. But anyway, at least the Leyden jars looked better. And here they took really copper Litz wire, which is much better. But you can see the conductive sectors, nevertheless, they are also by this wire. They are getting scratched away because it's still too hard. The single strands are not fine enough. Anyway, let's try to measure if we can measure the capacitance of the Leyden jars. You can calculate them because there exist formulas for the capacitance of Leyden jars. You only have to guess the dielectric constant of this plastic, but nevertheless I got a few tenths of picofarads out of them. And let's get our LCR meter and see if we can measure at least some capacitance, because not only does the inside and the outside coating have to be conductive, you also need a conductive connection to these metal combs to take off the charge from the rotating disc. And also the outer foil or the outer plate from both capacitors are connected via this bar. So we should be able to measure a capacitance between here and here. If not, we have a problem again. So let's get our LCR meter, set it to 100 kilohertz, because the capacitances should be relatively small, and see what we get. Well, that's nearly zero. This 4.77 picofarad. They are probably simply the capacitance. You can see here this is much too low. I can't believe. Now we have 4.7. Let's try the other one. Okay, there. That's around. I calculated, in fact, 100 picofarad with some guessed values, and 130. This looks good. Perhaps the screw must be tightened more. see, here we have only a few picofarads. So let's see if we can improve this. This is really a mess. This screw apparently can't be... What construction is that? Damn it. Really damn it. No. So there is apparently no conduction to the inner capacitance, to the inner conductive tape. Let's see where this, what is not connected. All right, the outer layer does not seem to be connected. How comes that? Perhaps I didn't firmly screw it. No. The other one, the working one, does show something jumping around between a few hundred ohms. But here we have nothing. So, okay, let's take out the LCR meter. Perhaps this has disturbed the measurement. Once again, yeah, the right Leyden jar gives a result and the left one doesn't. So let's see what could be wrong with it. Here you can see the little wires, okay, and you can already see the broken plastic in even more than one place. So how did they do the connection? Let's open this. Ah, man. This is really a mess. Did they glue this together or what? It looks like the plastic is already breaking into pieces when you try to open this. They probably glued this together to make it irreparable. Damn it. So perhaps with a bigger screwdriver we can get this damn thing. Yep. Ah, what a big self-wound spring. That looks really good. And what did they do inside? It's a little bit of aluminium foil. Oh my God. So we can simply try to unscrew this now and see where the problem is. So they tried it to make it better than the first non-working Wimshurst machine. But let's see where the problem is. No, we have no conduction between the aluminium foil and the screw. And again, this cannot work that way if you don't have a conducting connection. The other connection should be halfway working, as you can see when the big spring is making contact. So, and what also becomes clear, I'm 100% sure that the manufacturers of these Wimshurst-Machines, they never tried out their own machine, if it really works. Probably you won't find a video about them. I just can't believe how bad this is manufactured. Perhaps we can try with, I do have some spare aluminium foil to make this contacting the screw here. So sorry, I've lost some footage where I did show how this Leyden jar was repaired. In fact, with some of this aluminium adhesive tape, I could re-establish a successful connection of the outer aluminium tape with the connection down below. And so let's measure if we get the same 130 or even 140 picofarad now on this side, and on the other side we should have, yeah, there depends a little bit. I would have to repair this also. You can see sometimes it goes to the same value, 130 and something picofarad, depending on how I wiggle this. So this Leyden jar has the same problem as this one before, with a bad connection. But we now know how to repair this. Okay, now the Leyden jars are okay. In fact, if you're wondering what this apparently short circuit bar is for, it connects the common outside plate of the Leyden jars together, which is necessary because the voltage is then between where the spark gap, where the sparks are flying, is between the positive and negative, or the other way around, depending on how the starting charge is divided between the two plates. But in the meantime, I recognized, even if all is set as it should be, the neutralizer bar are set 90 degrees apart and around 30 to 45 degrees in angle between the metal combs. Nevertheless, perhaps you can see there are also some damages to the metallized sectors, but I recognized these are the metal sectors are not made of the same shiny aluminium tape or foil like the Leyden jars. They look like it's the same material as from the first Wimshurst machine. And if we try to measure any resistance, nothing. So, although the Leyden jars are better, so that we could at least make them working, this machine also will give no sparks because the metal sectors are in fact not metallized but also insulating. So this machine also cannot work. So we could even try if this works even against our prediction, but I promise you, let's make you can see how loose the discs are. All the machining is, here is too much space, so you would have to tweeze that again. And my goodness, this is really the worst mechanical design I've ever seen. The Chinese are really the world record holders in screwing up any kind of engineering, although there are probably better engineers also. But what they sell on Alibaba and AliExpress is really hopeless junk in sometimes. So everything is loose, my goodness. Let's try to fix this, at least for this test, sufficiently to give a demonstration that it certainly cannot and does not work. So I adjusted everything as good as possible, and you see how wobbly this thing is, but and as incredible as it may sound, I really get a few sparks. I'll try to make it visible a little better for you. So the sparks, of course, between the two I don't know how this is possible with the non-conducting sectors on the acrylic discs, but we get sparks. Unbelievable after some repair. So the Wimshurst machine seems to be quite forgiving to bad design and bad mechanical engineering. Let's see if we get even larger or longer sparks. Yep, these are, I even can smell the ozone from the sparks. Let's see how large we can make them. Yeah, that's already 4 centimeters, and again a nut from the crank has turned loose. My goodness. So let's go to more extremes and place the electrodes quite far apart. Now that is no, even over 4 or 5 centimeters. Incredible. The thing is working. And the ozone smell becomes heftier. So I never would have thought that this could be made working, but it is. So now I'm more happy than I would have thought before starting this video that this thing could really be repaired. Nevertheless, don't buy this one. I have another one that is a kit made from a German engineer that is mostly made out of cardboard, but it takes many weekends to assemble. I will link in a video where you can see a working model of the one that I'm at the moment assembling. So nevertheless, oops, there was still charge in it. Oh, you can see how long the Leyden jars can store their energy, their charge. I just got bitten a little bit, so be careful to discharge them. And for a finish, let's produce some more sparks. So that was it. Thanks for watching. Bye from Roger. Bye from Kanka Labs.